Okay. Hello, comrades, and welcome to my stream. And in today's stream, we are going to try to do something with the OBS plugins, and we will address this part of the screen, and I will try to show the thermal information of the laptop. Hello, comrades. Hello, Konstantin, and I'm doing all this wrong. I'm sorry. So I'm setting it up a little bit. Okay, good. So we are going to try and update basically this label that you can see here. So what we are going to do? So first thing that we are going to do is we need the utility to control OBS, and we also need to set up the OBS plugin for that. So the tool that I'm talking about is called OBS CLI, and it is written in Go, which is very convenient, as you will see later. So let me switch to OBS so that I can actually see what I am presenting as well. So yes, the tool that I am going to use is called OBS CLI. It is a regular Go tool, so I installed it using this command, so you can see that I did indeed do it, and I have OBS CLI here. And the tool also requires OBS WebSocket, which I also downloaded and installed into OBS. One thing to keep in mind is that I'm streaming from the MacBook Air that is on ARM. It doesn't have a fan, so the thermal information will be very useful. And I'm not used to streaming, so I'm sorry for switching windows too quickly or something like that. So I have tested this already, so I have the thermal info label. I think, yes, I called it thermal status. So I can change it from the OBS CLI, and it will be, of course, not hello world, it will be called hello comrades. So as you can see, we can use it to update the text from the command line, and we will go from there. Also, we will need to use VS Code, and I have it for, set up as well. And let me open a new project. So let's say it will be called OBS Tools, OBS Overlay. I set OBS Overlay, and I could not edit the text for some reason. Interesting. I think I found a bug in macOS. Okay, I need to rename this. So it will be called OBS Overlay. Okay. So we will open this directory, and it will be a Go module as well. So good. So I will align the window as best I can, and we will create some file like main.go, and for now it will only print hello comrades, and we should be able to run it as well. So something like go install and OBS overlay. Something like this. Oh, of course, we need to initialize a module first. And we need to give it a name. Okay, let's say we will give it something like this. We should be able to install it now, and it shows hello comrades. Great. So what we are going to do next is we will use the another utility that comes with macOS. That is called Power Metrics. So you need to run it as root. And what it prints is some information about thermal pressure, GPU usage, CPU usage, and things like that. So we are actually going to really care only about, probably only about GPU and maybe even not GPU. We will only care about thermal pressure for now. So we will say that we will continuously print this thing. And it by default updates it every 5 seconds. So we will run this tool from the command line. So let's say OS or exec. Actually forgot how to launch a subcommand. I think it is called os/exec. Pretty sure about that. So just checking that everything is working. Yes, so I think I am remembering it now. So let's say this, we have the command and error, and we do no. How again do we call it? Oh, exec, of course, exec.command. And we need to run sudo and power metrics. Things like that. So we will run this. And it should return an error. I think I'm not sure. I forgot already. I think it doesn't actually return an error. Yes. So we create a command. And we then say that we need stdout pipe. We will read from the stdout, of course. I think it also can give you an error, so if it gives you an error, then obviously we don't have much to do, so cannot just bail out. So we say that we cannot open stdout pipe. If we could, however, then we need to start the process as well, of course. And after we started the process, we will be able to read from the output of this command. So we can say could not start. It should never happen really, but everything happens sometimes, so we need to handle it. So we will create also a buffered reader to be able to read line by line, and we will go into the for loop and read string. set string read. Yes. So we will read a single line. Yes, it also can fail with an error. That makes sense. So we will also exit in this case. So could not read the line. And if we can read the line, then we need to see the output of this utility, and the only thing that we care about now is the current pressure level, right? So this is what we will search for in the string. So we say if strings has prefix this, if it has this prefix, then we need to update the string to say that we have some thermal pressure. So we will say that pressure would be this string without trim prefix, without this prefix. And we will then execute the another command that is OBS CLI. Yes, so we will execute this. And I think we should, yeah, we could not just execute it, but we will do the best we can. So we will do OBS CLI, change text, then the label that we have is thermal status, and we will update it with pressure and probably with something like this as well. So we say thermals, and we need to basically run it, and that's it. We don't care about the result, because if it fails, it fails. Doesn't matter. We need to keep going. So in theory, everything should work now. So we can try to run it. So we need to enter the password, of course, and wait for 5 seconds, and we should see the, yep, the overlay is changing, and we see that the thermal status is normal, so everything is okay, which is of course great. We can see that the temperature is actually 77 degrees, but it is fine. So we now should see that everything is working. So what else can we do? So we can, let me run thermal metrics once again, or as a power metrics. Says unable to get backlight node. I don't know what it means, but we can see more stuff here. So we can see that there is, for example, GPU frequency, GPU percentage usage. We can see how much power the laptop is consuming, how much power is the efficiency, are the efficiency cores consuming, and things like that. So we can try to take a look at all of those things as well. We can also see the running tasks. We don't really need it. We can also see the network activity, disk activity, interrupt distribution, things like that. So I think Power Metrics can actually show you all the tasks that it has. So for example, I don't know what SFI is. So we can try to take a look at SFI. Selective first idle. We see nothing here. Okay, so tasks, battery, network, disk, interrupt sources, I guess. Devices, CPU power, GPU power, and bandwidth. What is the difference between network and bandwidth? I'm curious. Okay, it is giving a lot of things. So I guess the bandwidth is not a network. It is the internal counters. So let us then try to parse the CPU power next. So we will request two things, CPU power and what is it called? And thermal things as well. So I think that what we can show is probably like GPU power and package power. So let us stick with those. So GoPLS, we can try to update GoPLS. It's a very good idea, I'm pretty sure about that, doing that in the middle of the stream. But it succeeded. So OBS overlay is still running. So we could try to extract this function into this code into a different function, and we can try to define some type that will be called like I don't know, stream info, where we will populate different fields. So we'll say that thermal pressure is this. Let me check that everything is running. Great. So we will check that thermal pressure is this. We will also want to show CPU power consumption, and I already forgot, we want to show yeah, I think it is called package power, because you know the processor that the ARM Mac has, this processor is actually a single package. What I mean by that is that how do I phrase it? So it is a single chip. So everything on I guess the whole processor is like a single package, a single chip inside. So I think this is what they're referring to as package power. So they call like the whole processor and P cluster. I guess P cluster is a performance cluster, and E cluster, efficiency CPU cores cluster. They call it as a package power, as a package. But we don't want to show so much detail for our comrades, so we will just call it CPU power. And we will then show GPU power consumption as well. So we then can define the state. So we'll say, I don't know, info is a stream info. And we will define a function that will update the current status using this info. So we'll say this, and we'll say update with the current line, and we'll write some like switch case, and it will look something like this. So we can do like, yeah, so we might not always want to write if statements, and we don't want to update the text just yet. So we will do this. So we will compute the pressure, and we will say update this value, and we will do it for other values too. So for example, GPU, if we see the GPU power prefix, and if you see the package prefix. So GPU power, if we have this, we will say that GPU power equals basically the same. We trim this prefix. And the package power is the CPU. I think it should be CPU. And we say CPU power equals string prefix package power. So then we will, after we read the string, we will update this info. And what we will then do is to show yes, we need to include CPU power here, and we will only update the text when we see the end. So let me show you. And I will probably need to update the to enter the password a bunch of times. So as you can see, the last line is actually about current pressure level in this case. And so we only need to update the text when we read about current pressure, because it comes last. Because otherwise we will call update text for every parsed. So we will basically call the update text 3 times instead of 1 if we only trigger the update when we have read everything. So we will only update when we receive the last line. So we will say that if strings has prefix this, we will also leave a comment that the thermal info comes last in every update. So we will say that if we received this, only then we will call OBS. And I need to copy this line first. Where is it? Yes, so, and then I guess we can do it once again. So if it is last, is the last line, I don't know, then we do this. And is last line, we will say that has prefix, this line has prefix current pressure level. And then we will update the thermal status with 3 things, right? So say status will be GPU, let's say CPU first probably. CPU consumes this, GPU consumes this, and thermal is this. So CPU is info CPU power, info GPU power, and info pressure. And we will update it with status. So if I did everything correctly, we could just relaunch the program, enter the password, because it is running as sudo. And we should see in 5 seconds that the stream is updating with the new data. Yes, great. So we now see the CPU, GPU consumption, and let me adjust the stream a little bit. Good. So we see CPU, GPU consumption, and how much thermal throttling is there. So, but how do you verify that this is what is actually happening? Let's run a game and see that the GPU, you will probably see frame drops, comrades, I apologize. for that in advance, because I'm streaming from this laptop as well. But let's run a game. You can also see that I'm launching Steam and CPU power consumption is already going up. Let's run a game. Let's say Kingdoms and Castles. Doesn't really matter, to be honest. So let us run something. So you can see that CPU power is going up. And it is white, so you could not see anything. I probably need to add a shadow or something. So let me try to do that. So that drop shadow. Maybe outline even. Yeah, let's add an outline. It should help a little bit. I don't know. You probably can see at least something. Maybe I could make it bigger. Just a second, comrades. So filters. No, filters. Properties. And my camera turned off. I'm a professional, as you can see. So let's say drop shadow and outline. I don't know. Should be okay. So you can see that the GPU power, GPU is power consumption is very high. So we can load Moscow. It will take a while, yes. So far, actually, the game seems to work just fine, interestingly enough. But it consumes about 15 watts of power, so it will probably overheat very soon. So I can see that my laptop, yes, you can see thermal is moderate, and you probably see lags in the stream, so I'm exiting the game. But you can see that GPU is actually... the GPU is being used, and that the actual numbers that we see are in fact correct. And you can see that we have moderate thermal throttling, so it is not too bad right now. You can see that it is like 96 degrees here. So it is going to get worse with time if we continue to do so. So streaming and playing games is probably not a very good idea on a fanless MacBook Air that I have. So now what we probably want to do is to make it so that we run the sync when we... So basically we are currently running it in the console from Visual Studio Code, which is not great, so we need to basically make it more consistent, more reliable. So one thing that we can do is we can, for example, run it at least in the terminal. So when we say this, I say go install, and we run OBS overlay. Great, so it will be running in the terminal, so if we should start seeing updates once again. So yes, we are starting to see updates. And if we close Visual Studio Code or something, we would still see the updates. Yes, great. So we are running it at least from the command line now, so it is a bit better, although it is probably not ideal still. You might want to run it as a service in macOS or something like that, but it works for now. So what else can we do? So because we can update anything in OBS, we can we can do... 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 we can do really different things. I haven't thought what I would do, because I thought it would take much longer than this. So it is actually pretty simple. So if you have any ideas, comrades, what would you like to see on the stream, you are welcome to ask any questions. So one thing that doesn't work in OBS, and I'm running the Intel version of OBS, is I think you could not get web views. So a web view is a thing that when you can add, I think it's called browser source, yes. So I will try to create a browser source right now, and I don't know, maybe show google.com or something. Actually, it works, interestingly enough. Maybe. You could not interact with it, I think, is the issue. But no, I think it does work, strangely enough. So you could also have a browser in... so, I don't know, let's open another page. So yes, you could have a browser. Yeah, you could interact with it. It is a bit weird, but... So yes, you can run a browser and show anything you like there as well. So... I thought it would not work, but it actually does, which is interesting. Anyway, I will delete it for now. So... what can we do? So let us try to do this. So currently we are using OBS CLI, and we are calling the OBS CLI command, but we can take a look at how it actually works. So I think that it probably has, maybe it only has a main package. That is unfortunate. Let's take a look. So it it uses OBS. Okay, so there is this package that is called OBS WebSocket, and what it does is it connects to it, and it receives a timeout of 2 seconds, and it connects to it, and that is it. And it also says that execute this thing. So let's take a look. So the stream. Oh yes, so there are several Cobra commands that are registered, and what we care about is change text.go. So we will see this. So we see OBS WebSocket. It says changes the text label, and how it works is that it basically all it does is calls this code. So we can copy this code to try to actually talk to OBS directly, and we will not use the OBS CLI command. So let us also create code like change text. Let's say that it is still package main, and we will say change text. And what do we need? So we need, so we need 2 arguments, source and string. And I guess we will also receive the error. But what we also have is that so this OBS WebSocket thing, I guess it is initialized. It is initialized as a global variable. Yes, so let's add it to our Go mod file as well. And our client, I guess, is as a client thing is defined here somewhere. Yeah, so client is the OBS VS client after all, so this is good. So we'll say that this is this. Does it send receive? Yes, so send receive does get the client pointer. So this is it. And so far we only use this code. We only copied this code from OBS VS, and we need to actually establish the connection as well. So we will do this. Yes, so after we start the power metrics, we will yes, great. So we will create the client, and by default we connect to localhost and port 4444. So we will connect to this client, and I guess we need to actually also connect. So we will do something like this. Log fatal could not connect to OBS client, and that is it. So let's see, undeclared name client. Yes, so we will not use global variables here. So we connect to this. We also probably send the timeout in the same way that this thing does. And then we will, instead of executing the command change text, every time we will just change text from Go code. So we don't have to even run any commands at all. And the result should be the same. So we will stop the OBS overlay. We will relaunch it. It also prints something into console, which is interesting. And I need to enter the password because, yes, it failed 3 attempts. I don't know what I'm doing wrong. Yes, great. So we should still we should start seeing the updates. Yes. So we don't need the OBS CLI tool to talk to OBS after all. So we can use this Go code, and because it is written in Go, we can just update everything, and that's it. So we can also try to reduce the timeout, for example. So the power metrics thing, you can see if you can enter the password, of course. Yes, so you can see that it has a bunch of parameters. So I think one of these things is the interval. Yes, so I and sample interval, and sample interval is probably in seconds. Oh, actually it is milliseconds. Okay, so we'll say that we can update it faster than that. We can update it every second, for example. So we will say every 1000 milliseconds is what we are going to do. And retry. I think, yes, we are seeing updates every second. So this is good. What we can also do, we can try to see CPU usage, but I'm not sure how to do this yet, to be completely honest with you. So there are probably several options. So one thing that I can do is definitely to show load average. It is not the same as CPU usage though, so we'll have to see. So one thing that I know is that there is Golang, macOS, get CPU usage. So I guess there are many tools that we can have. But let's say we can try like GoPSUtil, for example, or something. So let's take a look at what it actually can show you. So original metrics, CPU, load average, CPU cores. So on Mac, I think it actually doesn't work all that much. So I know I already did that in the past, so bear with me. Show CPU. Yes. So I made a Reddit post on how to show CPU usage when you're playing Stadia. And yeah, so this package, Go Stat, it can show you CPU usage on Darwin, although it requires CGO, but we might actually, it might still work. So we might want to try to import this package. So go get this package and we can try to use it. So there is this package memory. There is a similar package that is called CPU, I think. Could not save the file. Okay. So we then should be able to get CPU as well. So CPU get, yes. So CPU.get will, I think, yes. So I think what it does is it returns you the stats, and maybe it returns you an error as well, which I don't know. We probably shouldn't ignore it. So we only get it. We can only get it if we don't have any errors. And so we can, let's say we will print the status total. So let's say total would be 0 and see what the status 0, what it actually prints. And it is uint64, I think, yes. So we'll say CPU usage. It is total, right? So we will print it and see what it does. It is not a string. Let's print it as a value instead. And okay, it's doing something. Oh, great. So we, oh, I think, yeah, so we see empty lines because we actually don't need to, yeah, I think, yeah, we have a, basically what I was trying to say is that we need to remove spaces everywhere. So we have the end of the line everywhere. So it is not, so OBS is actually working well. And we need to, in order to remove the extra lines, we need to just remove spaces, and we will have, yes, so we'll have a tighter text. Great. So maybe it is even too tight, but okay. So we now see some counter. And as far as I understand how it works, if you actually want, yes, so if you actually want to get the CPU usage or something, you need to get a value before and after you sleep, and like get values, get values before and after, and then divide by the duration in I guess in a second actually. So maybe not. Maybe yes, you take a difference between total. Yes. So you record the total before value of total before and after. Then you record the value of user, system, and things like that. Also before and after. And then you divide one by another, and you get the percentage of resources that were used in that interval. Yes, I finally remembered. So what we will do now, so we will, so we need to store the previous stats somewhere. So what we are getting here is CPU stats. So we will say before and after. CPU stats. And we'll say that we obviously we assign after here. We assign after. And we can show the CPU usage line if we have before and after information. So we'll say if error is nil, that's okay, but we need to show like CPU usage sync. Something like this. So we will print CPU usage. And if we so anyway, if you don't get an error, we will assign before to after, and we will be able to at least compute it next time. And then we need to say that if before is not nil, then we can compare the current value and the previous value that we got. And basically copy this code. So something like this. So CPU usage will be this. So it will be user this percent, and system will be this %. And that will be enough for now. And we will make it pretty in just a moment. So we need to check that total is not 0 as well. So because we couldn't divide by 0, and it will be a disaster if we divide by 0 here. So we should see something like this. So let us retry. Okay. Unknown event type. Doesn't matter. Oh, okay. So we see something. So first thing that we probably need to change is we need to remove. We have too much detail, and we probably can remove some symbols to make it shorter as well. Yes, great. So it is still not very good because we see too many lines here, so we probably need to. Yes, it is still too much. And we can also say that before we can actually populate the before value already as well. So when we start, we just get the counter, and that's it. So when we start, we get the CPU value, and then like 1 second after that, we will get the CPU value once again. And if they are not nil, then we can show all the details. Okay, so we will do this. And what do we see? Yeah, so so we see now the percentage of CPU used, both user and system. We see how much the CPU consumes. We see how much GPU consumes, and we see that the system is having like moderate thermal throttling. So it is not operating at full performance, but it is good enough. So let us see what else we can show here. So it can show load average. It is pretty useless, I think, as well as uptime. It is pretty useless. I think what we also were able to show, yeah, how much memory is consumed. So let's say we only really care about how much memory is used, because cached memory is memory that can be reclaimed by the operating system. So yes, but before we do that, we need to do something with this mess. So what I think we need to do is to extract all of this into a function. So let us say something like this. So we'll say get CPU usage or something like this as a string. And so and we invert all of this logic. So if error is not nil, then we say we can actually print it as well. So we say we get an error message, we print it, and we just return. So it is easier this way. And we need to assign the value of CPU stat anyway to before. And we don't need after. So we need we will return the CPU stats and a string that can be used to format the CPU usage. And before will be also the CPU stats that we received before. That we computed before entering the cycle, because when we compute the CPU percent or something like this, we also we want to compare the difference between the number of resources that was used before and after the measurement, because we need to measure like CPU usage over 1 second or over 2 seconds or something like that. So if before is nil, then we just return after, and we could not print anything, sadly. So we even say before is nil. And I have a very cheap camera, so I need to restart it every 30 minutes to continue streaming. Anyway, you could also notice that it consumes a lot of CPU to stream the camera as well. So let me reformat it. Yes. So the CPU usage is what we are returning. Error is also not what we want. So if total is greater than 0, then we can return after and this. Otherwise we return after is the new value basically, and say that total is 0. So because we return some text in every case, we can actually debug the issues with that thing as well as we go. So we get CPU usage. We can then call it, of course. So we only call the get CPU usage when you receive the last line, so when we update the text. So we say that before and CPU usage is get CPU usage. And CPU usage is probably still needs to be defined. So we define a string CPU usage, then we update the previous value, and we compute the difference and we print it. And in theory it should work. And I think we need to also always, yes, we always need to print the end of the line, because we will not print the empty string at any moment, so we will always need a separator between those. So let us try to rebuild it. Probably more than 5 minutes passed, so I need to enter the password once again, because Power Metrics needs root. And I could not do this with 3 attempts. Probably need to just enter it more slowly. So something is happening. Oh, it actually works, look. So we have, yes. And I already forgot that I also wanted to print the memory usage. So actually it would be different. So CPU before it will be called. So CPU usage and memory usage are computed differently. It will be called CPU before, and we can actually declare it like this. Yeah, so we don't have to define a variable here. And we can also get the memory usage, and I think memory usage we don't need to know the before and after. So we say memory dot get. I think it will automatically import the correct packet. Yes, it does. So we get memory. Yeah, so the same will be mem usage will be a string, and if error is nil, then our mem usage will be something. So we will say it will be memory, and I think it is reasonable to assume that memory is nowadays counted in gigabytes or gigabytes, which are powers of 2. So we will say memory used and divided by, so a gigabyte is 2 to the power of 24, I think. But it needs to be float 64. And here as well. So if we just divide integers by one by another, we will get we will not get a float result. We will get an integer. So the remainder will just will be lost. And so we need to use floats here, and we will print memory usage here. And restart. And we need to do go mode tidy so that we register the version. And so we see that 88 gigabytes is used. What do you think, comrades? So I have 16 gigabytes of memory on my machine. Does it sound reasonable that it is 88 gigabytes? I don't think so. And I also think that I screwed up when dividing things. I think maybe not. Oh. First of all, it is not 2. It's 1 to the 1 and 24 zeros, right? Binary zeros. So let us think a little bit. So 8 will 2 to the 8th power will give us kilobytes. To the 16th power it will give us megabytes, and to the 24th power it will give us gigabytes, right? I don't understand why it says that I am using 88 gigabytes. I don't know. Let's print free memory instead. And let's see if it makes a difference. Okay, so I have 6 gigabytes free. And my stats utility also shows something actually not, it doesn't show anything. So we know that we actually have 496 megabytes free. Oh, I'm not showing you, so sorry, comrades. I need to show you this. So I have the iStat menus, and it shows that it is like 500 megabytes. It is not 6 gigabytes free memory. So I screwed up somewhere, and I couldn't understand where, to be honest. Do you have any ideas, comrades? What can be happening? So let's take a look. So memory is in bytes, right? How can it be that the memory used, memory free that I see is so much different? What am I doing wrong here? So first of all, let's remove the division at all. So let's print like exactly how many bytes it thinks there are. So we'll say bytes, and we say this. So free is uint64. Yes, great. So we will restart. And we see that it is, what is it? $92 million bytes. Is it correct? I don't know, comrades. So, okay, let's say gigabytes. So gigabytes is the... Most definitely the gigabytes is the powers of 10. So it will be 1000, 1 million, 1 billion, and it will be gigabytes. So let us restart once again. And what do we see? Dot F, 1F. So we see that I have 0.1 gigabytes free. It is also incorrect. Interesting. Okay, let's say we have used memory. Maybe it is going to be better. And we restart. And it says that used memory is 3 gigabytes. It is also incorrect. So we actually have 6 gigabytes used. I think it is safe to say that it is just incorrect. Oh, I think comrades, I think I know what is going on. So in ARM architecture, the page size is different. So I think what it tries to do is it gets VM stat. Then it collects memory stats and says page is free, page is active, and things like that. And it multiplies it by 4096. And the page size in ARM macOS is different. So if we run, I don't know, free, there is no such command as free. Great. Memory pressure. Interesting. There is a command that is called memory pressure. So it shows that 85% of the memory is free. But how does it compute that? So yes. So we, in this command memory pressure, we can see that the page size is actually 16,000. Yes, so the page size is 16,000. Just a second, please. Okay, I'm back. Sorry for that, comrades. So we have the page size of 16 kilobytes. And this library multiplies by 4096. And you would think that this solves our problem, right? So we just multiply the used by 4. Sorry for that as well. So because this library uses 4 kilobytes, we just multiply by 4, and that is it. But I think we will also get incorrect results. And yeah, so it now shows that we are using 12 gigabytes, which is closer to the real thing, but not quite. So it shows that OBS is using 8 gigabytes, but the overall used memory is only 6 gigabytes. Interesting. Let us take a look what is going on actually. So let's open the system monitor. So I think, comrades, actually this multiplying by 4, of course it only applies to ARM architecture, so this is definitely one thing to keep in mind, but actually it is pretty close. So if we so physical memory is 16 gigabytes, but I think it is actually not gigabytes, it's gigabytes. So if we just say that it is 2 to the power of 24, and I don't think you can do that. So 1 to the 24th power. I think it should give us the correct number, so it will be gigabytes. Let's restart this thing. Plus infinity. Yes, I think you need to do the shift in the different direction. So no, I don't understand. I don't understand how I could screw this up, but let's say 1 to 24. It is 16 million. Yes, it doesn't make sense. That is because it is not 24, it is 30, comrades. So 1 kilobyte is 10 to the power of 2 to the power of 10, and not to the power of 8. I should have known that actually. Yes, okay, so we see 11.4 gigabytes used. That is close enough. I don't know where the difference comes from. So probably the difference comes from the fact that OBS is an Intel binary. And on Intel architecture, the page size actually is 4 kilobytes still. So for OBS, we need to calculate differently. So probably actually this is correct and it shows gigabytes and not gigabytes. So we will go with this thing. So it will be 1,000, million, billion. So it will be close enough, so should be okay. So we have used we use 12 gigabytes of memory here. I guess I can also prefix the thing that it is M1 MacBook Air, so that it is a bit clearer what I am running it on, and I don't have any. It doesn't have any fans as well, so I think this is the correct spelling here. And yes, so it is saying that it is heavily thermally throttled, and I'm wondering if you see any dropped frames or something, but so far it seems that it actually is working well enough still. So I don't know if it is probably... Yeah, so user... let's say memory is used here. User and system. Let's try to format it a little bit better. I don't know if it... Yeah, so let me add one extra space here so that it looks a bit better. It probably won't be perfect if you don't make a font with the appropriate font, but with the... what is it called? Monospace font, so that every letter, if it is the same width, then we could make it work better. Maybe I could change it now, so I will go and change the font to maybe do something like, I don't know, Monaco. Yes. So we could actually now format the text properly. So it will be CPU like this, GPU like this. Let me check. Way off. Okay, so okay, so it is formatted somewhat well. We are running at 83 degrees Celsius, but this is because the GPU is thermally throttled. And CPU is throttled as well. So we could show more information, but before we do that, we can do the following thing. So now every time I save the file, I need to restart this tool. And I think it would be great if we could somehow, trigger the rebuild every time something changes. And to do that, we can there are multiple options. So one thing that we can do is to use there is a package to observe the file system changes. It works for Mac too. So macOS golang macOS notify about file system changes. Yeah, so this is called fs notify, I think. I'm pretty sure. So yes. So we will download it. We'll do go get first, and then so basically what we will do is that we will write another small program. It will probably be somewhere here. We will call it rebuilder, and what it will do is not gp, main.go, and what this thing will do is observe file system changes and trigger the rebuild and relaunch the utility that we have. So let's say import both things actually. So let us do this. So we will just copy the code from here. What we need to do is that if we have an event, we don't care about errors, to be honest. But whatever. And we will watch the directory with, so we will watch this directory, basically. We can maybe hard code it for now. Yes, so let us run it. So we will go and say rebuilder and do this. So then when we modify any file, we should see an event that the file was modified. So when we see that the file was modified, we trigger a rebuild. So we also need to probably, I wonder if we are running a bunch of power metrics binaries now. I hope not, but we can. So we will see the power metrics binary probably somewhere. We only run a single power metrics binary. That's good. But we probably still want to terminate it. I guess we could not terminate it from here. Okay, never mind. So yeah, so what we want to do is that we want to like see that the file was modified and then wait like a second and then relaunch everything. So we will do this. So we go. So first we will probably need to, yes, let us do this. We will change the current directory to the directory with the source. We observe the current directory, and what we will do is that if we see a write, we will do go install, maybe -v, and we will run it. And if there are no errors, then we will stop the current binary and run it again. So let's try this. So I think the binary that we are running is called OBS overlay. So if we just run kill all OBS overlay, yes, so it is terminated. I wonder if we have power metrics still running. No, we don't. Maybe we do. So no, we don't have power metrics running as well. So it is alright to terminate only the... We actually have no way of terminating power metrics anyway, because it runs as root. So we can call kill all OBS overlay after that. So we will do this. Kill all OBS overlay. And we will run it. And then we will start OBS overlay in the background. So we will say something like go. We'll start the overlay. And if there were no errors when we started the OBS overlay, we will wait until it, and we don't really care about what happens to it. So we just don't want to leak the descriptors, the process descriptors here. So in theory, that should be enough. So we will kill the previous version and we will start a new one. Of course, it is not going to be killed immediately, but that's fine. And we will print to a log something like we will print something like rebuilding and say just for a good measure, we will say that when we are running OBS overlay, something like this. So we also might want to make sure that the output as to the in, as to the out, at least as to the out, is OS as to the out, and as to the error is OS as to the error. For the OBS overlay, so that we can see the actual log lines from the OBS overlay that is running, if you want. So I'm pretty sure that it is not going to go smoothly the first time, but let's try it. So we will run the rebuilder and go run main go. And did it do anything? I don't think it did, because we need to modify the file. Let's just save it and see if it is. Yes, so it is. The one downside is that Power Metrics requires root to run. We probably can do something about this. I couldn't enter the password. Let's try again. Okay, so yes, I think we see that the stream is being updated. Great. So we can now just save the file and we don't have to relaunch anything. Unless like we need root to access to enter the root password once again. So let's say, I don't know, let's change this text. ARM MacBook Air. So we should terminate. Yeah, so it works. I wasn't expecting it to work, but yes, see, running OBS overlay, rebuilding. I'm honestly surprised that that it did work, but it did. So I will return the M1 MacBook Air. Okay. So we can now iterate more quickly. So, and memory consumption is not present, I think. Where did it go? Mem usage. I think we could no longer get memory usage. I remember it was there, comrades. Do you remember it was there just a second ago? So let's say that we actually do care about errors and just say that, I don't know, memory has some errors. Or even, oh, okay, so swap usage operation not supported. How did this happen? Comrades, do you remember it running just a minute ago? Okay, fine. I guess we don't need it. Okay. So we can do a lot. So let us then finally take a look at the processor frequency. So we have two, so the MacBook Air and any ARM processor actually from Apple, or a lot of ARM processors, and probably every. Okay, so German is suggesting to exec free. So the thing is that there is no free command. There is no such command called free in macOS. I don't know why. But like I couldn't run the free because it is not present. So I don't know. It is strange. It is not present on, at least on my ARM Mac. So I couldn't run it. Anyway, so let us do this. So let us try to print the frequency of the processor. So we have, so there are two processor types in M1 processor. So there is energy efficient cores and there are performance cores. And I think that the so what they call E cluster is the energy efficient cores, and the P cluster is performance cores. So we could extract this information from power metrics as well. So we have it already being printed. So we will do this. Thanks for help, Comrade German, anyway. So party appreciates your effort. And if you find out how to get memory usage on ARM macOS, please don't hesitate and tell everyone. Or if you have any other ideas, that is always appreciated. So we will say efficient. I don't know how efficient is spelled. Efficient core frequency, cores frequency, and power performance core, performance cores frequency. And for some reason saving a file takes time. I think we have an error somewhere. Yes we do. Yes, it is formatted now. So efficiency cores frequency will be this. So and the what is it called? Performance core frequency will be this. So performance cores frequency will be that, and we can then print it. So memory usage and CPU usage, okay. So performance core, perf core will be this, and efficiency core will be this. And we will print it as so performance cores and efficient cores. we probably need to split the formatting code. I don't know, should I make the font smaller? You probably could read it anyway. But let me know if you couldn't read the text. I think you still could read the text, so I can make it a bit smaller, and this way we could fit more information here. So I added a space here as well. Yeah, so we see... Great. So maybe I will add an extra new line here as well, and restart. Okay. So let us try launching a game once again and see how much CPU, how much memory. Oh, we couldn't see memory, sadly. How much GPU consumes and stuff like that. So we will once again let us launch something else, Civilization 5. And the stream will probably start dropping frames at this point. So I'm sorry, comrades, if you will see dropped frames. Yeah, so OBS says that encoding overloaded. So this is probably a clear indicator that something is going wrong, but it is still interesting, I think, to see what kind of CPU usage and things like that is being used by a game. If it loads, it takes a while. Okay, so click to continue. Great. I don't know, single player, load game. Don't have any loaded games. Just play now, I guess. So we should see CPU usage go up, probably. And you see that performance core is dropping frequency a lot, so it actually is dropping below the efficiency core frequency. But I can still play, like I can build some city, I can go scout. So the GPU is probably consuming, it's actually not consuming too much. It's consuming like 1 watt. Okay, so it is interesting to see that the games actually do affect. And performance core had to drop frequency a lot after that. So you can see, comrades, that the performance core's frequency returns to normal after the game. After I stopped playing, even though it says that the thermal throttling is heavy, but it is still so it is still not as bad when we launched the game. Yeah, I couldn't say, I'll say throttling instead. And we will need to work on the formatting of this thing after that. So let me think. So first thing that we can do is probably use those quotes instead of what we are using now. So the backticks, they allow you to basically have a raw string here. Actually don't remember what we show here. Just a second. So okay, so we show this. So let me reformat it this way first. So we can see that we can align everything here and here. I'm moving the wrong part, I'm sorry, comrades. So, and we no longer have to do two new lines. Okay, so user. So this thing is formatted here. And this is because user and system games are not using GPU core correctly. So I think that the performance cores are used like for user interface, and the efficient cores are used for background jobs. So you should see the GPU consuming more power when we launch games. So you can, yeah, I have made it a bit better probably. I hope so. So everything is aligned now. So yeah, so I'm showing the all the system or some of the system metrics on the stream, and when we launch a game, you should see that the GPU starts to consume much more power, and CPU probably should drop a little bit in terms of power consumption. So let me launch a game once again. Let's say, yes, C5 probably will do. So we can see that when I'm launching C5, it immediately starts consuming more user and system CPU, but also it should start consuming GPU power. So the power is in milliwatts here. So basically the more milliwatt, basically 1 watt is 1 volt times 1 ampere, if it makes sense. But like the more milliwatts GPU consumes, it means it is working more. So the game is loading now, so it probably is consuming CPU, but now it should start consuming GPU, and you can see that it is indeed consuming some GPU. And when we launch a game, so when we launch anything basically, once it loads, when it is loading, it is consuming CPU as well. But when it starts to draw so basically it draws the map, you can see that it starts consuming GPU as well. So we see that GPU it was consuming like 300 milliwatts, and now it is consuming more. And we will see that if we were not already heavily throttled, you would see that because GPU consumes some power as well, the overall power consumption is increased, and we will see throttling as well. So it is not magic in terms of how it operates. It couldn't really handle streaming and gaming and streaming this web camera all at the same time while running Intel translation. I think it is not as powerful. Yeah, so OBS says that encoding is overloaded right now to me. But we basically see that the processor is maxed out. Almost maxed out, because you see that and you see that the performance cores, so the performance cores that should be like 3 gigahertz, they only run at 800 megahertz because of the thermal throttling. And to be honest, I'm surprised that it works that well. I don't know how many frame drops you see on the stream, but the game actually does not lag to me. So I'm honestly surprised. Maybe definitely settings for games. Apps. macOS using Wine. iCloud closed source code Apple. I actually don't really understand what you mean. So you see 5 to 10 FPS. So for me, I see 60 FPS in the game, but you don't see the 60 FPS on the stream, because I think OBS doesn't get as much CPU. But it's definitely too much for the MacBook Air to play games and to stream, at least with the camera on. So if I turn off the camera, let me show it to you. So I can turn off the camera stream, and you'll see that the user and system CPU will drop a lot. So without the camera, I guess I actually need to turn it off. Or remove. Yeah, so I will turn off the camera. It actually consumes more. I don't understand. I really don't understand. But when if I turn off everything, if I turn off the camera, streaming, if I don't just hide the stream, but if I just turn it off completely, then the CPU usage drops by maybe 10% or maybe 20%. So the actual video camera that I'm using consumes a lot of CPU as well. So I can show you system monitoring here. So OBS is consuming 142%, and then VDC Assistant, which is the virtual driver for camera, it consumes another 30%. So I don't know what I'm trying to tell you. So the limiting factor in MacBook Air is definitely the thermal throttling. So if you have M1 MacBook Pro, I think you would get much better results. So you would not see the CPU dropping in terms of performance or in terms of anything, basically. So you would not see any thermal throttling. And maybe OBS will run fine as well. I don't think so. I think it is still too much, because it is doing software encoding right now. But it will probably do much better than now. Anyway, I think for today I am actually done. I don't know what I can also add to the stream in terms of system metrics. I think I will use this overlay for a while when I'm going to stream something else. And let me know if you have any ideas on what you would like to see about Go, or about anything that you would like me to talk about in the next streams or in the next videos. So, yes. Thank you a lot for this unplanned stream, for participating in this unplanned stream. And looking forward to seeing you in the future, comrades. I don't understand. What is MBST? What is MBST? MB, probably you mean by MB, you mean MacBook. Oh, you mean I don't understand. I'm sorry. uh, you mean, oh, in top. So like, yeah, maybe I could show top, but top on Mac as well is strange. So, it's all really strange, to be honest. So let me show you what top on Mac looks like. It is very strange. So it is not like top on Linux at all. So it shows you, yes, it does show you CPU usage. It shows you some kind of memory usage, but I think it is too much information to be displayed on the stream as well. So hard to tell. But yes, top IO top systat. So IO top, I guess I can. Maybe sudo IO top then. Maybe IO top I can run it. But the thing is that you need to parse this information. Oh, IO top is very strange. It doesn't work. Doesn't work at all, I would say. Okay, systat. There is no such command. I can try to install it. So yes, install -s. Install from source. There is no systat as well in Homebrew. So the system metrics on a Mac is a different thing than on Linux. Oh, you mean, okay. Yeah, maybe you're right. I guess I could run top and just parse its output. But I think top also consumes a little bit of CPU, although it's not much. It's like 2% CPU. So maybe that is alright. Yeah, I guess that works. That might work. If we run it. So it shows that, so for example, it shows that 4.5 gigabytes are used. And it is, it is still different from everything else. So let me see. Memory used here is showing as 9.7 gigabytes. And and the top actually shows that 13 gigabytes is used. So it probably counts cached plus, I don't know. They all so top iStatista and Activity Monitor all show different values for memory usage. That's hilarious, I think. Maybe I could run memory pressure instead. So there is this command memory pressure, and it shows you how much memory is available for the system. So maybe I can show this instead. I guess I will use it instead, honestly, instead of everything else, because yes, it's hard to get memory. I think we are also not showing Oh, it tried to rerun and wants my password. This is another thing that we need to address actually. That if it reruns in background, it wants to run power metrics once again. And I need to enter sudo password. I guess what I can do is actually power metrics. Yeah, so we can do this vsudo, and we could allow everyone to run power metrics without sudo, or rather with sudo but without any password. So let's say sudo run command without password. So I think so yes, vsudo. Yeah, this doesn't. I want a specific command to. I want to allow a specific command. So we could do sudo ers.d. Okay, so we can do this. So user, if your user is called user and host is called host. Okay. And which power metrics? So user bin power metrics. Great. So we want to allow running power metrics. User will be Yuri and host is host name, this one. So we will do this. We will allow to run power metrics without a password. So let's take a look. Power metrics. Seems to work. But we will. Yeah, so this one thing that it probably needs to do, our rebuilder program needs to do is to actually run OBS overlay as a start. So we will write a function like this and do func run OBS overlay in background and do this. Or maybe we could do even better and don't start a go routine in this function, and we just do it even better in terms of Go style. Okay, so we will run OBS overlay as a start. So there is definitely, yes, so civilization definitely is running through something like Wine or something like that, but it doesn't really matter, right? Because with any game you would get this. It's too much. It's just too much to ask from this MacBook Air. Remember that if we go over like 50% of CPU, it means that we are starting to use efficient cores, and like efficiency cores don't really offer much performance. So they, like, I think 4 efficiency cores offer as much performance as 1 performance core. So if we go over 50%, we basically could not get a reliable stream. Okay, so great. So we are running everything, and I think we also even addressed the sudo issue. Alright, so we did achieve our goal of writing the OBS overlay in Go, and we even rebuild everything when we save the file, so we can iterate on this overlay in the future as well. And we don't require sudo password because we entered the sudo, we changed the sudo config so that we don't need a password to run power metrics. And that is it. So thank you for watching, comrades, and at some point I will actually learn how to use OBS and how to change scenes, and everything will be great. But until then, thanks for watching, comrades, and see you sometime in the future.